All right, today we're doing implicit differentiation and inverse functions. Implicit differentiation is really, really important to know because we're going to use it quite a bit. So you really need to know and pay attention to this. Okay. So if we have x's and y's in the same function, two different variables, and we're finding dy dx, that's saying find the derivative of y with respect to x. Okay? So when we take the derivative of y with respect to x, I'm going to skip over the 2xy for right now. This is just 3x squared, just like normal. The 3y squared is, what would you think? 6y, but we're going to put a dy dx behind it. Okay? Equals, what's the first derivative of 5? 0. And so this first one is 2xy, which is really 2x times y. So it is the product rule. So 2x, what's the first derivative of y? 1 dy dx. It's 1 dy dx. So you got to put a dy dx. Whenever you take the derivative of y, you have to put a dy dx behind it. Plus, then y times, what's the first derivative of 2x? 2. You don't have to put a dy dx behind that. Okay? So, it says find dy dx. It's right there. Stupid math teacher joke there. Where it says find x, it's right there. Not x equals 7 or whatever. So when you find dy dx, you got to get dy dx alone on one side of the equation. Ooh, how do I get dy dx alone on one side of the equation? Well, I move everything that's not multiplied by dy dx to the other side. So I have 2x dy dx minus 6y dy dx equals negative 2y minus 3x squared. Because if they're positive on this side, if I move them to the other side, they're negative. Now, we're going to factor out a dy dx to get 2x minus 6y. Then what do you think? How would we get dy dx alone? Divide by those. 2x minus 6y. So, the answer might be this, or it might be that. What's the difference between these two? All my negatives. If you take everything by negative 1, it becomes the bottom one.
Wait, so the answer is both, or it's just one or the other?
It's one or the other. It's not both. Well, I mean, it is both, but they could have one or the other listed as the answer. So understand that they might factor out a negative out of everything and put it as a more positive answer. Whether it's AP or Khan Academy, they might do that to you. Okay? So, what is dy dx? It's the first derivative, which is the slope. So we can find slopes of equations like this at any point. Okay, now, so I'm going to grab the Desmos graphing calculator for this because it's a lot better than the TI graphing calculators when it comes to something like this. So if we look at our equation, Our equation was 2xy plus x cubed. So it's I wonder if it'll let me do this. I might have to type this. So 2xy plus x cubed minus, and then 3x squared, 3y squared equals 5. And if we zoom out on that, it looks like that. That's the nature of that equation. So now we can find the slope at any point on that equation. Okay? How would we find the slope at any point on that equation? Well, we find a point where it goes exactly through, like, any points that it goes exactly through. They're not really, we're close. Oh, right there. At something 6. At 4, 6, it goes exactly through there. So if we put 4, 6 into that first derivative, if we put the point 4, 6 into that derivative, 2 times 6 plus 3 times 4 squared over 6 times 6 minus 2 times 4. So we get 12 plus 48 over 36 minus 8, which is 60 over 28. Divided both by 4, 15 sevenths is the slope at that point. Just slightly bigger than 2. Okay? So let's practice on that. So this is not just a guessing game. I think it's going to be that one. No. You actually have to figure this out. Okay? Because it'll be very frustrating playing the guessing game on this assignment. Okay? So, how do we take the first derivative of this? What's our first term? 4 minus, and then we have to do the product rule. So it's x squared times dy dx, because we don't even have to say 1 anymore. And then it's minus again, because it was minus in front of it, minus y times, what's the first derivative of x squared? 2x. So I'll just leave it the 2x in front, call it 2xy, plus, what's the first derivative of y cubed when it's dy dx?
3y squared dy dx.
Equals 0. So if we take the dy dx's and put them on the same side, you get 3y squared minus x squared times dy dx equals, move the other stuff to the other side, 2xy minus 4. Because this becomes positive, that becomes negative, and divide by 3y squared minus x squared. Okay? And then we put the point 1, 2 in there. So 2 times 1 times 2 minus 4 over 3 times 2 squared minus 1 squared. Well, the top becomes 0, right? The bottom is 5, so it's 0. Okay? That's implicit differentiation. We found the slope at the point 1, 2 of that crazy graph. Okay, let's do that one more time. Implicit differentiation. What's first term going to be? 3x squared. Second term?
4y dx.
4y dy dx minus x dy dx minus y equals 0. Okay, because the first derivative of x is 1. All right, so 4y minus x dy dx equals y minus 3x squared. Divide by 4y minus x. So if we stick in 0, 1, it's, or 0, negative 1, it's negative 1 minus 0 over negative 4 minus 0. Negative over negative is a positive 1/4. Okay, implicit differentiation. We're good on that. Okay, inverse functions. Okay, y equals x squared and y equals the square root of x are inverse functions. Okay, y equals x squared looks like this. Y equals the square root of x looks like this. So they cross this magic line of x equals y. There should be the mirror image around that. Okay? Also, y equals like 2x plus 4. Its inverse, if you remember how to do this, is, remember we switched around the x and the y. So x equals 2y plus 4, and then solve for y to find the inverse. So move the 4, x minus 4 equals 2y, divide by 2. So y would equal x minus 4 over 2. So these two are inverses of each other. So y inverse is this. So if we would stick a, let's stick a 3 in here. What's 2 times 3? Plus 4 is? So this is the point at 3, you have the point 10. If we stick a 10 in here, what do you think we'll get? We should get 10, 3. The ordered pairs just flip around. Okay? That's important for this. Okay, so let G and H be inverses of each other. The following table shows what G of X is, what H of X is, and what H prime, the first derivative at H is. If we want to find G prime of 0, or the first derivative at 0, what do we have to do? Well, in order to find that, we should find an expression where the first derivative of x for any input of x, okay, which is this formula, 1 over the first derivative of h times the original g of x, okay? So if we plug 0 into that formula, what's g of 0 going to be? What's g of 0? Here's 0. G of 0 is? Negative 2. So then you want to find h prime of negative 2. Well, h prime of negative 2 is negative 1. So you have 1 over negative 1. So it should be negative 1. So in this one, okay, if we want to find, that's the same problem, right? Okay. Don't I have another table one? Oh, I should have put another table one on there just to practice with this. But I guess. All right. So let's say we want to find G prime of 11. G inverse of 11. Now, if we know f of 2 equals 11, what do you think G of 11 will be? Probably 2. Now, if we're doing first derivatives, G prime of 11, if we look back at our little cheat sheet, g prime of the number is the regular g and then h prime of the number. So it'd be 1 over f prime, f of g of 11. So what's g of 11, did we say? 2. So it would be the first derivative of f at 2. So we have to find the first derivative of f, which is 3x squared plus 2. So the first derivative of 2 would be 3 times 2 squared plus 2. What's 3 times 2 squared? 12 plus 2 is 14. So we should get 1 over 14 as our answer by following this formula right here. Okay, so it's the g of the x that you're given. Plug it in. You find the first derivative of the other function, if they're inverses of each other, and go 1 over that. Okay, those are inverse functions. So before lunch, you're working with implicit differentiation first, and then inverse functions. They're out there for you. You can get rolling. After lunch, we're taking a quiz over chain rule and that. You know what I did?
What did you do?
You forgot to record.
No, I recorded. You know what I did? I have done something very bad. I did
The wrong lesson.
Friday's lesson.
I was like, this is not what we have.
Okay, hey, let's do today's lesson. Okay, so let's do today's lesson because I was getting ready for tomorrow.
Oh yeah, I won't be here on Friday.
Hey, you guess what? I just taught everything about Friday. Who's all gone Friday? All of you, basically?
With what?
Wow.
Yeah.
Wow.
Okay, so I'm glad I taught Friday's lesson today.
Yes. Thank you.
Okay, let's do Thursday's lesson.
Wait. So how about this? Let's do this. Let's teach today's lesson. Then let's do all of the assignments and then quiz.
I'll just put the quiz out and you guys have till whenever. Let's take till Tuesday to get the quiz done.
Okay.
We're good. I'm good with that. Okay.
We're good. We're chilling.
All right. So more chain rule. Okay. Remember the chain rule is like if you have f of x equals. Ooh, I gotta unfreeze now. If we have f of x equals x squared plus 3x plus 2 to the 5th power, this is the inside function. So you take 5 times the inside function to 1 less power times the first derivative of that inside function. Okay? That's the chain rule. That's the basics of it. So, if we want to find the first derivative of f of x of g of x at x equals 1, okay, we take the inside function, g of 1. What does g of 1 equal? 0. So then we have to find f of 0 times the first derivative of g at 1. Okay? We have to find f of 0, or f prime of 0 times the first derivative of g at 1. Sorry about that. So, f prime of 0 is -3. G prime of 1 is -2. What's -3 times -2? 6. So that's a chain rule using tables. Let's do another one of those. f of g of x, where we're doing g prime of 2. So what is g of 2 equal to? G of 2 is equal to 1. So we have to find the first derivative of f at 1 and the first derivative of g at 2. So it's 3 times 0, which is 0. Okay, that's the chain rule using tables. Last one of these. Okay. F of g of x at x equals 1. So g of negative 1 equals what? 1. So we have to find the first derivative of f at 1 and the first derivative of g at the original number, negative 1. First derivative of f at 1, first derivative of g at negative 1, which is 7. Just multiply them together. Okay, that's the chain rule using tables. Now, this goes on your note card. The first derivative of a to the x is a to the x ln of a. Because these are the two I don't remember ever. But if you're taking the AP test, you gotta have them in your memory book bank somehow. I'm sorry. So the first derivative, this is like 5 to the x power. The first derivative of 5 to the x power would be 5 to the x power times the natural log of 5. Really kind of weird, but that's how it works. And the first derivative of the log base a of x is 1 over x times the natural log of a. So whatever your base is, you're taking the natural log of that base times x and having 1 over that. Okay? So when it comes to this section, the problems can be really easy if you recognize patterns easily. If you're somebody who can recognize patterns quickly, this assignment should take not very long. Okay, so if it's negative 12 log base 5 of x, okay, the negative 12 is out front. It stays out front. If something is out front, is it in the numerator or denominator? Numerator. So the negative 12 should be in the numerator. Log base 5 of x. Well, the base is the ln of that number, and then whatever x is, it's x. So it's natural, it's choice A. Okay? Now this is the a to the x thing. So negative 8 is out in front, negative 8's in the numerator. Well, then it's 7 to the x power. So it's times 7 to the x power times the natural log of 7. So it's negative 8, 7 to the x, natural log of 7, it's a again. Okay? 3 times 5 to the x is same fashion as this. It's not a log. So it's 3 out front, 5 to the x times the natural log of the base. So that should have one more. Yep. Negative 8 log of x. What's your base on log if there's not a base written down? 10. So negative 8 is out front, so that's up top. On the bottom, it's the natural log of 10, and then times x. So it's choice B. Okay? And then finally, just you'll have a few more chain rule problems. So what is just the sign of just plain and simple x? What's the first derivative of that? Cosine of x, right? So if it's a sine of something complicated, it's the cosine of something complicated times the first derivative of the something complicated. Okay? So it's the cosine of that times the first derivative of the inside, which is that. So it is choice A. So e to the something, e to the x, its first derivative is e to the x. E to the something complicated, let's say it's e to the y, is e to the y times the first derivative of y. That's the chain rule. So it's e to that times the first derivative of, which would be choice D. So everybody got that? So let's find this at -1. What's the first derivative of that? Well, the first derivative of the square root is really 3 minus 7x minus x squared to the 1/2 power, right? So it's 1/2 times this to the -1/2 power times the first derivative of the inside of it, which is -7 minus 2x. So the -7 minus 2x is on the top. 1/2 times the square root of 3 minus 7x minus x squared is on the bottom. Now we're sticking a -1 in for each x. So it's -7 plus 2 over 1/2 of 3 plus 7 minus 1. What's 3 plus 7? Minus 1 is? Square root of 9 is? Half of 3? Oh, not half of 3. It's 1/2 times that, so it's 1 over 2. So it's 2 times 3, which is 6 on the bottom. 1 times -5 is -5 on top. It's -5/6. Okay? All right. So I will put out that other assignment as well, but that's all stuff you can work on. There's another one. I mean, this is like super easy. Log base 4, so you're looking for the natural log of 4 on the bottom.